This video is over topic 35, numbers 4 and 5, looking at investment or annuity calculations. So again, not using the formulas that Alex will tell you to use, using these calculations here. So the PMT, the FV, a little bit here, because this is similar sounding to when you have compound interest, it'll even use the word compounded. So when you see compounded, you want to look for, is it a what we call lump sum investment, or is it a repeated investment? If it's a one lump sum investment, you'll use the P times 1 plus R over N to the NT. If it's a repeated investment, you'll use the FV, future value formula, in Excel. So that's something to be aware of, to look for. Other than that, FV, it's kind of a reverse of the PMT, takes a total amount that you're borrowing, finds the monthly payment that it'll take to get down to zero in a certain amount of time. FV, you're starting at zero, you're putting in this amount each month, it's earning interest, and you're looking for the total that's going to end up with the payments you're putting in plus the interest being earned. But similar, we have a total invested, that's the amount per investment per payment or per deposit times the number of times that happens. Total interest earned will be the final future amount minus the total invested. So I'm gonna get what I want this here. So we have those annuity calculations, and we're jumping to question 4. So an investor wants to save money to purchase real estate. He buys an annuity. When you see annuity, that is also a cue that you're going to use FV. Quarterly payments, so that's important. We're using N equals 4. So don't get in the habit with PMT, it's I think always going to be 12 monthly. With FV, there's more of a mix. Sometimes it'll be annually, sometimes it'll be monthly, sometimes it'll be quarterly. So the N here, same as in the 1 plus R over N to the NT, depends on how often the payments are made. So quarterly payments, compounded quarterly, we're going to use 4 for N. The payments being made at the end of each quarter doesn't matter. It's always going to say that. So 5.6% interest, and each payment is 181. He does this for 17 years. So in Excel, we're going to do equals FV. Uppercase, lowercase, doesn't matter. As you can see here, the R over N, or what you have on the formula sheet, it's described as the periodic interest rate. That is going to be the annual rate, 5.6%, or 0.056, 0.056 if you want to get real fancy. But either in decimal form or with the percent symbol. So again, not just 5.6. And then that needs to be divided by, so /4, so divided by N, then the comma, so that's the R over N times T, 4 times 17 to find the number of deposits, comma, and then the deposit amount, or the payment amount, is, so this is the number of deposits. And then we have the deposit amount, which is the $181. So put that in here, equals FV parentheses 5.6% divided by 4, comma, 4 times 17, comma, 181, and parentheses. And it comes out 347.46. Again, it's showing up red. If I put it in with a negative 181, it'll come out black. It'll be the same number. If I do 0.056 divided by 4, 17 times 4, because I can do that multiplication in either order, it's fine. If I do a minus 181, then again, same number. So on the project, you will be asked to put a minus because you'll be using that result in other calculations. So you'll be setting up it'll be a PMT calculation, I think, that you will be using the minus to make sure that the answer shows up in Excel as positive. All right, number 5. This is very similar to what you'll be doing in homework activity. The number homework activity 9. So we have Sue is retiring in 26 years. She's going to deposit $105 each month in a 401k account that pays 7% interest compounded monthly. So this is a repeated investment. She's putting in an amount each month. That's going to be FV. So repeated investment is going to use FV to find the future value. Or what that means is the ending amount. So we'll get to that. Then Sally is also going to be retiring in 26 years, but she doesn't feel like putting $100 away each month right now. She's like, I'm not going to do anything for 13 years. And I'll wait half the time. 13 years, I'll start making deposits and I'm going to invest the same. I'm going to put the same amount of my money in, but I'll do it starting 13 years from now. And I'll do it for 13 years instead of 26 years. So first, total amount Sue will be investing. So that's, she is doing $105 per month for 26 years. If I just do this and I'm writing my units, these don't work. So I need a 12 months per year in there. So she's not just doing the $105 26 times, she's doing it 12 times, 26 times. So that is a total. Again, I have Excel up. I'll just use it on my calculator and put in equals 105 times 26 times 12. 32,760. All right, for Sally to end up putting in also 32,760 of her own money, but doing it in 13 years instead of 26 years, I want to have whatever amount going to get multiplied by 13 and by 12 to still get 32,760. So we've made the 13 half. So we've basically taken out, it was 26, which is 2 times 13. And I just have the 13 here. Then I need to take that 2 and instead combine it with the 105. She's going to invest for half the amount of time. She's going to have to invest twice the amount per time. So 105 times 2, which is 210 per month. So now we have Sue putting in 105 per month for 26 years, Sally putting in 210 a month for 13 years. And we're going to look at their totals. So Sue's account after 26 years of investing, it's going to be equals FV. It's going to be her 7% interest divided by 12 because she's putting in monthly. 12 months a year for 26 years, and she's putting in 105 per month. For Sally, we're just changing the 26 to 13 and the 105 to 210. So we have for Sue equals FV parentheses 7% divided by 12, 12 times 26, and 105. She ends up with 92,507.56. She put in 32,000. He's gone up almost triple what she put in. Sally, just making a couple tweaks here. In fact, I'm just going to go here. I'm going to double click on this. I'm just going to go change those numbers 26 to 13, 105 to 210. I have one number doubled another, and it comes up a very different number. She ends up with 53,199.47. Put in the same 32,000. She's only gained about 20,000, she's less than double. All right, we're going to do some comparisons. Goes way back to early topics, first week of class. Can we do these comparisons? Sue will gain how much money on her investment? She has gone from, she's at 92,507.56, and she put in 32,760. So the extra is what she has gained. So, in fact, let me do this. This was 6 and the 105. But then I could just again have Excel do that. I'll say equals. In fact, let's do this. Make this minus so this comes out positive, so I don't have to worry about adjusting for that. All right, so I'm going to come over here and say, all right, take this thing minus the 32,760. And then I can say, all right, do the same thing on the other one. So Sally's amount. So Sue will gain 59,747.56, which is what percent of what she put in. Just looking for the percent gain. We already calculated the amount gain, so I'm going to take that, this result, divided by the amount she put in, because it's of what she put in. So divided by the 32,760. Take this, divide by 32,760. Not be a dollar amount. This should be a percentage, 182%. So 100% would be she got as much as she put in, doubled her money. 100% increase would be double. She's more than 100%. She's almost triple, almost 200% increase, 182%. Sally, as we see already calculated, gains only 20,439.47. That's taking her 53,199.47 minus the 32,760 that she put in. And if we again repeat this percent formula, so now it's taking this one divided by the 32,760. It's less than 100%. She didn't even gain as much as what she put in. So for Sue, we would have something kind of like this. Her whole balance, the whole circle is her whole balance. This is what she put in. This is what she gained in interest. For Sally, it is more like maybe something like this. Interest and what Sally put in. And of course, Sue's whole circle is bigger because the what they put in is actually the same size. Okay, Sue's account ends up having how much, more or less? Sue's account has more than Sally's by how much? Let's go in here, and I'm just going to say take this guy minus this guy. 39,308 and 10 cents. Sue ends up what percent, more or less, still more. For the percent more, I'm going to divide by than Sally. I'm going to divide by Sally's total. So whatever it's than. Also, the percent more means I need to divide by the smaller. So I'm going to go here again, let Excel do a little work for me, equals, take this guy, the result here, divide it by this smaller total. And I can even, again, go to Excel and say, hey, make this a percentage for me. And 74%. Now, what it is doing on these percentages, all of these, it's rounding to a whole percentage. So if I want, I can go and say, hey, give me another decimal place on these. So like this was actually 182.4 and 62.4 and 73.9. So that's pretty much what you'll be doing in homework activity 9, as well as you'll have homework questions in Alex doing some of these types of calculations as well.